Good morning. Today we're going to look at isosceles and equilateral triangles. We're going to start with the isosceles triangle quickly. We know from the definition that an isosceles triangle has two congruent sides. We call those legs. So here's a leg and here's a leg. Let's take a look and see what happens with that. So with the isosceles triangle, we realize that the isosceles triangle theorem happens. If you have an isosceles triangle, in other words, you have two legs that are congruent, you automatically get the two angles on the bottom, called base angles, as being congruent. So let's see how we use that. Here's an example of an isosceles triangle. It's marked with these two pieces. This double marks mean that they're equal. I know it's isosceles with that, so I can just simply write out an expression that says 2x minus 3 has to equal 27. From there, it's algebra. Add 3 to both sides. 2x equals 30, and x must be 15. So that's using the definition of an isosceles triangle, knowing that these two legs are congruent. Now we're going to use the isosceles triangle theorem. Again, I notice that these two legs are congruent, which means I automatically understand that the two base angles, in other words, the angles opposite those legs, are also congruent. So these two are congruent. That tells me that 3x plus 7 has to equal 28. So 3x equals 21, and x must be 7. Okay, it's your turn. Please take a minute to pause the video here, try these two problems on your own, and I'll give you the solutions in just a moment. And your solutions. Notice on the last example, again, the isosceles triangle theorem tells me that these two angles are congruent because these are the two sides. My triangle is just turned sideways. Okay, next we're going to look at the equilateral triangle. The equilateral triangle, by definition, has three equal sides. Well, because it's got three equal sides, two of those sides right there make that isosceles. And these two make this isosceles. So you can tell, it turns out that all equilateral triangles are actually isosceles triangles, and therefore all of those angles are congruent. Let's look at an example of an equilateral triangle. Again, it's clearly marked that the three sides are congruent. Therefore, I know that these two legs are congruent. And I can simply write 5x plus 2 equals 27. Subtracting 2 from both sides, I get 5x is 25 and x is 5. A second example uses the isosceles triangle theorem, but this time inside an equilateral triangle. I recognize that I have an isosceles or equilateral triangle, so I know that all three angles are equal. So this 3x must be equal to this 60, and obviously this 60. So I'm going to say that 3x is equal to 60, and now divide, and x must be 20. Okay, it's your turn. Try these two on your own, please, and I'll give you the solutions in just a moment.